Hello, ladies and gentlemen, and welcome back. Root Beer here, continuing, or I guess rather concluding, our look at the Grade 8 Gauss paper from 2018, because we're on the last question, question 25 now. So what have we got? In the 2x12 grid shown, Ashley draws paths from A to F along the grid lines. And then we have a list of conditions here. In every path, there are 2 or more arrows arranged head to tail. The tail of the first arrow starts at A, the head of the last arrow ends at F, just like the path they have shown. 2 consecutive arrows must be perpendicular to each other, so we can't do something like this and then follow it up with an arrow like this. They have to be perpendicular, so if I'm heading east or west, my next arrow is going to head north or south, and vice versa. Okay. No 2 arrows can intersect at more than 1 point. So I guess arrows could cross like this, because there's 1 point of intersection, but we couldn't do something like this, because then we'd be overlapping arrows again. Okay. And all arrows have different lengths. Now that's interesting, because if we have to alternate north, south, east, west facing arrows, the vertical arrows are quite constrained then. I mean, normally we could either do something like that, or like that, or like that, or that, or that, or that. I mean, those are the only vertical arrows we could have, but we could never have this arrow and this arrow together. That's not allowed, because they're both of length 1. That's going to constrain things a fair bit, but well, it certainly limits the paths she can draw. And I guess there's similar work with the 12, but the 2 really constrains things a bit. And then what are we being asked? The path from A to F shown consists of arrows of 3 different lengths, left by 2, up by 1, and then over by 11, because it's a 2x12 grid. Okay, that makes sense. How many different paths are there from A to F? Alright, so it's a counting problem. And in any counting problem, we're going to have to be careful. Got to have a good plan of attack. So here's going to be my strategy. I'm thinking play around with a little bit. I really think the paths are definitely constrained by that up-down stuff, so I want to focus on that first. But I'm going to play around with it with a little bit of theory, but I think, as this is kind of common for the late 2010s papers, with question 25, I think it's going to just be a lot of casework as well. So if we're going to be writing out possibilities, we want to be very organized and very clear. So one thing that's immediately coming to mind is, let's draw a copy here. It's 2x12, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And A is what? I think A was here, and then F was up here. Yeah, A is 3 over. So one thing we could do to sort of organize ourselves is, the simplest way to get from A to F is one of these, take exactly 2 paths. So we might sort of categorize by how many arrows we use. 2 arrows, or I guess we could throw in a 3rd arrow. I mean, they certainly do. That's a possibility. Now, they go left-right for their first one with 3 arrows. Could we go down? Yeah, we could go down, we could go over, and we could go up. So that's another way to do 3 arrows, or we could do some sort of Tetris piece Z shape as well. How about 4 arrows? Can we do 4 arrows? Oh, I'm not even counting the double length stuff as well. That's something to focus on. But 4 arrows, I suppose we could do something like that, and then that, then that, and then up. Certainly. 5 arrows? Can we think of a way to do 5 arrows? Maybe back, down, over, up, over. That's, yeah, okay. How about 6 arrows? And if I find many more, I think this is going to cause me a bit of a problem. Now, for 6 arrows... Well, let's see. We're on this middle row, as I say. If we start by going down or up, that burns our one length. Thing. And then we could go over or something. And then we have to do another vertical one, because they're always perpendicular. Now, we can't go down by 1, so we'd have to go down by 2. And that burns our length 2, and then... I mean, we can't go up by 2 again, so... The number of vertical arrows, and maybe yellow wasn't the clearest one to be using, I think the best we could do is left, right arrow, either an up or a down arrow of length 1, another left, right arrow, and then I guess it would have to be a down arrow of length 1, because otherwise you're already in the top spot. Then an up arrow of length 2, and then a left-right arrow. I mean, it could be either way, but I think 5 is the best that we can do. Okay. So that's a good, useful observation. Sure. Now, do I actually have to do 2 arrows, 3 arrows, 4 arrows, 5 arrows? I mean, that was my first instinct, but I'm wondering if I allow sort of a length 0 arrow, which doesn't really count as an arrow, so I guess we could have other length 0 arrows. That would be down, over, and up, and that's a length 3 arrow. I said that one. That was this blue one here. So if I allow for length 0 arrows, could everything fit into this mold? I guess not, because the one that they give us is a left-right arrow and then an up arrow. But yeah, I think there's really only 2 cases. Either something and then an up, something, or a something, a down by 1. This would be an up by 1, by the way. A something, an up by 2, and a left-right sort of something. And it's possible that some of these can be 0. Now, we can't have both of these left-right arrows in the first one be 0, because otherwise you're just starting at A and going up. But you could have multiple zeros. Something like this could be 0 and this could be... Now, I don't think the middle one could be 0, because then what would we be doing? We'd be going over, down, do nothing in the middle arrow. So for our third arrow, we'd be going up. Not only would the arrows be overlapping here, but that would also violate the you have to do perpendicular. So if I'm going to have this one down and this one up, I do have to have something that isn't 0 here. A non-length 0 arrow. But you'll notice that in my 3 possibility situation, the length 1 arrows are already taken, and then the length 1 and the length 2 arrows are already taken here. Alright, so let's try this out. So, I don't know, let's call this A and B. So A, we're doing some sort of length, some distance left or right, and then we're going up by 1. And then B, we go some distance left and right. Now, one of A or B could be 0. That's entirely possible. That would be fine. Now, I guess I should draw the whole thing. So we'll draw our 2x3 grid again. One for split it into 2 6s, split each of those 2 6s into 3s. So A was here. Now, well, maybe I shouldn't call them A and B, otherwise I'm going to get confused when I say A. So let's call them X and Y. Now, if we call them integer lengths, I can avoid having to call them left and, like, say, x is a length 3 arrow going right, or x is a length 3 arrow going left if I assign some positive or negative to them. So how about we say something like up is positive and right is positive. So we could start off with x being a negative 3 arrow. And that would mean that we've sort of used up the length 3, because we're not allowed to have arrows having the same length. All arrows have different lengths. So that would burn the length 3 arrow, and then we'd go up. That would burn the length 1 arrow, and then y could be anything other than 3 or 1 in length. Okay? But it has to make it to f, and so that's, I think, going to put another constraint on us. So x plus y has to be, it's 12 by, so it's 3, so it has to be 9. X and y have to be 9. Are there any other conditions I can see right away? Well, there's a limit on what x can be. X has to be between, it can be no less than negative 3, and it can be no more than 9. And correspondingly, y would then be, well, y is whatever's left over. As long as it's not 1 or whatever length x is, we're fine. So maybe we could make a little chart from here. So we could have x, and we could have y, and we could have, is it good or is it bad? So we could have a negative 3. So we go back, then we automatically go up, because that's sort of the template we're working with. And then we could go over by 12. That's allowed. We could have negative 2 and 11. Now we can't have x being negative 1. Yes, negative 1 is different than the number 1, but the negative really just means go left, not right. And so that'd be an arrow of length 1. We already have an arrow of length 1 built in, so it has something like that, but that doesn't work. Now we could have x be 0. That's perfectly fine. That just means we don't do anything and we go up first. So y would be 9. Can't have a 1 and 8. But we could have 2 and 7, 3 and 6, 4 and 5, 5 and 4. None of these are going to match up. And then we'd have 6 and 3, 7 and 2. And you can't do 8 and 1 because then y is a length 1 arrow. But we could have 9 and 0 as well. Now we go all the way over, and then we go up, and then we don't do anything. So that's what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 possibilities with the x up by 1, y sort of cases. Yeah, I'm pretty confident in that. Okay. So what about our other general situation? I think this is going to be a bit more complex, but we do some left or right, and this could be 0, so we might not do anything. But then we go down by 1, some left or right, and then we go up by 2, and then some left or right, and possibly 0 as well. But a constraint is y can't be 0. There has to be something between the going down and the going up arrows. And we need x and y and z to be equal to 9 if we add them up. And we need none of these values to be equal to 1 or 2 or equal to each other, excepting you could have x and z both be 0. Because that's just down, over, up to f. And that's perfectly fine, but that starts with 0 left-right motion and ends with 0 left-right motion. I guess the same sort of constraint on x, our first move, happens as well. These 3 here, it's going to be kind of hard. So x could again be anywhere between 3 and negative 3 and 9. But x can't be 1, and it can't be 2, and it also can't be minus 1 or minus 2, because those are just length 1 and 2 arrows going in the wrong direction. Now, I guess once we have our x chosen, I think we might have to break this down into cases based on is x negative 3, is x 0, is x, I guess the next valid one would be 3, is x 4. So once that's chosen, we sort of wind up somewhere. Then we go down, and then y has sort of a range of possibilities that it can have as well. What is the range of possibilities of y? Well, suppose we went over by 4. Then we've got, so a is here, and there's 1, 2, 3. So negative x plus negative 3 is the lowest that y can be. Yes? Yes. And then y also at most can be 12 plus that, so 9 minus x, and then the z is left over. So I think we can make another sort of chart almost. I don't think I want to make a chart, but let's sort of do it case by case. So negative 3, we move over by 3, then automatically go down by 1. We'll do something, and then we'll go up by 2, and then go somewhere. So the y needs to be between 12 and 0, but of course y can't be 0. So y could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the z would have to be x and y and z have to add up to 12. So x plus y plus z is 12. X and y, y and z have to add up to 12 minus x, which in this case is 15. So that's another sort of crucial condition, I think. So we'd have z. Z would have to be 14? That doesn't seem right. Oh, wait, what am I saying? 12. 9. Yeah, so 9 minus x. So in this case, they'd have to add up to 12. That makes sense. Okay. So you'd have 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, now we can't have 1, we can't have 2, we can't have 3 for y because we already have a length 3 arrow. Similarly, can't have 1, 2, and 3 here. And we can't have the 2 6s because then y and z have the same length. But this leaves me with 1, 2, 3, 4, 5 different possibilities. So we had 10, now we've got 5. Alright. Now, how about 0? Well, then y is going to be between 9 and negative 3. And y and z have to add up to 9. Yeah. 9 minus x, and x is 0. Okay, so what could we have? Well, we could have y is negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would make z equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now you can't have the 2 or the 1, and y can't be 0. Now, you might be tempted to cross this z off here because it's 0 and x is 0. But remember, length 0 arrows don't really exist. Okay, so it's not like Z has the same length as X. There is no X arrow. Okay, it's just a shorthand way of me avoiding having to deal with the 2 arrows, 3 arrows, 4 arrows, 5 arrows cases. Now I just have the 3 arrows cases and the 5 arrows cases. But zeros at the ends are perfectly allowed. So what would that last one correspond to? That would be do nothing, go down 1, go over by 9, go up by 2, and that's perfectly allowed. So that'd be 1, 2, 3, 4, 5, 6, 7. Oh, wait, hold on. What am I talking about? First of all, I just ignored the one I said should count just because it had some scribbles around it. And also, I forgot to get rid of 1 and 2 here. Just can't have those lengths as well. Have to watch for the Z's as well for a while. So I guess that's 1, 2, 3, 4, 5, 6. Okay. Now I think, so the next one's X is 3, so Y is between -6 and 6. Y and Z have to add up to 6. So we get Y and Z, -6, -5, -4, -3, -2, 1, 0, 1, 2, 3, 4, 5, 6. Now, I'm just noticing I don't have to write this middle part. You can never have a, because there's always a length 2 arrow, a length 1 arrow. Y is the only one that's specifically not allowed to be 0. So I can definitely cut down on my work here. 12, 11, 10, 9, 6, nope, 3. 2, this is a, wait a minute, what? Oh, sorry, this is a 0. And this is a 1. There we go. Can't have the 2 and the 1 there. Definitely can't have the multiple 3s, because that even conflicts with this X equals 3. And we can't have -3 for our Y value either, because that's a length 3 arrow as well. So what have we got here? That's allowed, 2, 3, and then 4 here at the end. Okay. We'll do. I think we might go through a quick double check at the end, but you know, I'm starting to feel a little bit more confident. The problem seems to be a bit more tame. So -7, -6, -5, -4, -3. Don't write any of the 2s, so the next thing is 3, 4, and 5. 0, 12, 11, 10, 9, 8, 2, 1. Those ones are off the list. Can't have anything that also has a 4 in it, so that's off the list. So that means 1, 2, 3, 4, 5. Okay. It's going smooth. X is 5. So that's Y is bigger than or equal to -8, less than or equal to 4. X and Y add, or Y and Z add up to 4. I don't know why I always say X and Y. -8, -7, -6, -5, -4, -3. Don't do anything with the 2s. 3, 4, so this is 0, 1. 12 is always at the top. 11, 10, 9, 8, 7. Can't have anything with a 5 in it. Can't have anything with a 1 in it. Did I cross out the 1s? Yes, I did. Okay. And I think that's it. Yeah. So that should be fine. Nothing with a 5 in there. 1, 2, 3, 4, 5, 6. Alright, X equals 6. Y is at least -9 and at most 3. I think that there might be a slightly faster way to do some of this. But because I'm noticing sort of some patterns, but nothing that I think is worth my time to stop, develop as an idea fully, and I don't think it'll speed up my calculations, because I'm making good time here. I'm obviously being a little slower because I'm having to stop and explain things, like why this 6-1 and this 6-1 are out. Other than that, everything else looks fine here. that's another 6. It might be a good idea to randomly check one of these, maybe the -5 and the 8. So what would that be? It would be A, go over by 6, down by 1, go back by 5, go up by 2, but that's allowed. You're allowed to cross once, and then over by 8 to F. Yeah, that looks good. Okay. So then x equals 7. So y is bigger than or equal to -10, and at most 2. And at this point, I don't need to write any of the other numbers because at most y would be 2, and you're not allowed to have a 2 anymore. So we have 12, 11, 10, 9, 8, 7, 6, 5. And that's out for length 7 reasons, and that's out for length 7 reasons. And so that just leaves us with 1, 2, 3, 4, 5, 6. 2 more cases to go. Y is at most 1. Y is at least -11. Stop writing there. 12, 11, 10, 9, 8, 7, 6, 5, 4. Can't have anything with an 8 in it. And so it should be 6 again, right? 1, 2, 3, 4, 5, 6. Oh, 7 now. I didn't cross something out, did I? No. Okay, that's 7. Alright, I guess it works. And lastly, x is 9, so y is at least -12 and at most 0. Yep. -12, -11, -10. And y and z need to add up to 0, but that's just going to... None of these will work. Because because y and z will always have the same length then. Just one's going in the left direction, the other's going in the right direction. Yeah, so none of these work. That's a 0. Okay, well let's add them up and see how many we've got. So 0. I'm just gonna grab my calculator so I can keep track. 0 plus 7 plus 6 plus 6 plus 6 plus 5 plus 4 plus 6 again plus 5 plus 10. We have a grand total of 55 when all is said and done. And I'm confident in that number just because we've been methodical. I'm not saying this is the only way to do it. You could have done sort of case 1, 2 arrows, and then 3 arrows. I just think as long as we're careful, we know which arrows could be 0. And I think there's probably a sneaky little trap. Where was it? Yeah, this Z being 0 and X being 0. I think maybe if you were going too quickly, you might not catch that those are allowed to be... They're both allowed to be 0. But yeah, 55. So let's take a look. Is 55 one of the answers? Yeah, they were all in the 50s. 55 is here. It's B. And that's going to close off the contest for us quite nicely. As I say, the 3 arrow, 5 arrow possibility, that's the way I chose to do it, but you could do 2, 3, 4, 5 arrows. They do say at least 2, but I think a key part of the start of the question is realizing you can't ever use 6 arrows the way they've made their paths. And then it's all about how you choose to break it down into cases and as how careful you are when you're doing those cases. But let me know, by the way, in the comments down below if you broke it down the way I did it, or if you used 2, 3, 4, 5 arrow cases, or if you did something else. I would love to know another way to do this question. It's definitely had a lot of casework in it. But that's it. We're done. All finished the 2018 Grade 8 Gauss. So, if you're looking for more Grade 8 Gausses, you can find them around my channel. 2017 Grade 8 Gauss would be another sort of similar level contest because it was made the year before. And 2019 Grade 8 Gauss as well is something to look around for. Yeah, I don't have anything else to say. I hope you guys have a wonderful day. Hopefully you've enjoyed the contest. I enjoyed it more or less. And I will see you for more math in the next video.